So in example 4, we're given the graph of y equals 1 over x squared. Do you remember graphing that one last year? Did he have a name for it or something? No? Sorry? No, it wasn't, no, this wasn't the angry clown. Oh, we call this one a volcano because it kind of looks like a volcano. Right? And there's like an asymptote right here, spewing lava. Okay, so we have an asymptote at x equals 0 and 1 at y equals 0. And this is the graph of 1 over x squared. Now we can apply all of those same things that we've learned in the past about moving things left, right, up, and down to this graph as well. The first thing we're going to do in part A is we're going to take that equation and just write it with y by itself, because that's sort of how we've been doing things along the way and we're more used to that. Now the question doesn't say to graph, the question says to describe. So when you get describe or explain, this is one of the key words that is going to be coming up on your exam in January. That means you're going to have to use words and full sentences to say what happens. So in this case, if we're trying to describe how that graph is going to be moved, well, we would say the graph, we could even say the graph of, here's our original one, y equals 1 over x squared would be, now there's a bunch of different words that you can say, like moved, shifted. The proper math word would be translated. And we want to try to use the proper words as much as we can. So the graph of y equals 1 over x squared would be translated which direction? Up 3, so 3 units up. As a result, it says, what are the new equations of our asymptotes? So there's two asymptotes, one that's x equals, one that's y equals. If you moved it up 3, would that affect your x equals 0 asymptote? No. So it's gonna, because it's shifting it up and down, it's gonna stay at x equals 0. But the y equals 0, 1 will now be at y equals 3. Same thing for part B. We're going to take the first step and just rewrite things. And again, one of the skills that you're going to get better and better at is being able to recognize if my parent graph was 1 over x squared, that this is related to that graph. Because I've still got a 1 over, and the x is on the bottom, and what's on the bottom is still squared. Then to recognize what's different. There's a plus 3 and a minus 4. Can you see that that plus 3 is inside where the x was? And so we say that's inside the function. That's going to move things left and right. And the minus 4 is outside of where the 1 over x squared is. And so that's going to move things up and down. So we can write our sentence, the graph of y equals 1 over x squared would be translated 3 units left and 4 units down. Questions for practice with this one, 16 and 17.